In this video, we're going to talk about how to take derivatives where the chain rule is required. So we have our chain rule right here. It says if f and g are differentiable and h equals f of g of x, then we have this equation. So first I want to talk about h equals f of g of x. This is a composite function where g of x is inside f of x. So we have an outer function and an inner function. So here f is our outer function and g is our inner function. So if I have a composite function, when I take the derivative, I'm going to start by taking the derivative of the outer function. So I have f prime of x. And then notice that g of x stays the same. My inner function stays the same. But after I take the derivative of the outer function, I then need to multiply by the derivative of the inner function. And that's what we're going to be doing for these examples. So let's go ahead and do some examples. Starting with number 1, I have f of x equals sine of x cubed. So every time you use the chain rule, you need to decide what is my outer function and what is my inner function. So for this one, my outer function is going to be that sine. So I have sine of stuff. So I'm going to start by taking the derivative of sine. Derivative of sine is cosine. If you're interested in a video for taking derivatives of trigonometric functions, I do have a video for that, and I will have it linked in the description. But derivative of sine is cosine, and just like our equation up here, I'm going to take the derivative of the outer function. I'm going to leave the inner function how it is. So x cubed stays as x cubed. But after I do that derivative of the outer, I'm now going to multiply by the derivative of the inner. So my inner function is x cubed. Derivative of x cubed is 3x squared. I'm going to rewrite it to clean it up a little bit. I get 3x squared times cosine of x cubed. And that is your first chain rule. Let's do some more. For number 2, your outer function is technically x to the 7th, but just think of it as I've got stuff raised to the 7th power. So when I do my derivative, I'm going to start by taking the derivative of x, or stuff, raised to the 7th power. So this is your power rule. So I have 7 times that stuff, decrease your exponent, so we have to the 6th. Your inner function, which is 3x minus 2, that's going to stay how it is. So I'm going to keep my 3x minus 2. Once you do that, I need the derivative of the inner function. So derivative of 3x minus 2 is 3. From here, I can do my 7 times 3, and I get 21 times 3x minus 2 raised to the 6th power. And that is your derivative. Number 3, we could have radicals when we are taking derivatives. I would rewrite this to be x squared plus 1 raised to the 1/2. Notice that your outer function is going to be technically x to the 1/2, but you can think of it as just I have stuff to the 1/2. That's your outer function. Your inner function is going to be this x squared plus 1. So g prime of x is going to be, I'm going to do my power rule with x to the 1/2. Your stuff stays the same. Decrease your exponent by 1. We get negative 1/2. Your x squared plus 1 stays the same. Now take the derivative of x squared plus 1, and we get 2x. To simplify, notice 2 times 1/2 is 1. I'm going to write this as x in the numerator over, I'm going to have x squared plus 1 to the 1/2 in the denominator. So I'm going to write it as the square root of x squared plus 1. That is number 3. Number 4, I have the natural log of 2x minus 1 plus x cubed. So you could have multiple terms for your derivative. This first term needs chain rule, the second one doesn't. So for my first term, my outer function is natural log, and my inner function is 2x minus 1. The derivative of natural log of x is 1 over x. So my first derivative for g of x, I'm going to have 1 over, instead of x, I have 2x minus 1. That all stays the same because that's my inner function. Multiply by the derivative of the inner function. Derivative of 2x minus 1 is 2. I now have taken the derivative of my first term. Now take the derivative of your second term. This is just going to be your basic power rule. Derivative of x cubed is 3x squared. To clean it up a little bit, I'm going to rewrite it as 2 over 2x minus 1 plus 3x squared. We've got a few more. My next one, I have e to the 1 over x plus secant of 2x. So I have two separate terms. I'm going to take the derivative of each term separately, but each of these needs a chain rule. So for my first term, e is your outer function. Your inner function is the 1 over x. And if it helps, rewrite this as e to the x to the negative 1. 1 over x is the same thing as x to the negative 1 power. Let's take our derivative. So I'm going to start by taking the derivative of the outer function. Derivative of e to the x is e to the x. It stays the same. So derivative of e to the 1 over x is e to the 1 over x. But now chain rule, take the derivative of 1 over x, which is x to the negative 1. I'm going to multiply by, do your power rule, negative x to the negative 2. For the second term, secant of 2x, my outer function is secant of x, my inner function is 2x. Derivative of secant of x is secant x tangent x. So now instead of x, it's 2x, secant 2x tangent of 2x. Take the derivative of the inner function. My inner function is 2x. So derivative of 2x is 2. Simplify a little bit. So I'm going to write this as, I have my negative e to the 1 over x squared, plus, I'm going to just write this 2 in the front of the term, 2 times secant of 2x, tangent of 2x. Next one. Now we're going to do some more difficult ones. For this one, I have two inner functions. So my outermost function is e. Inside my argument of e, I have sine. Inside my argument of sine, I have 3x. So I'm actually going to do chain rule twice. So let's do it. And you're just going to start with your outermost function and work your way in. So derivative of e raised to stuff is e raised to stuff. So this all stays the same. Now chain rule, I need to take the derivative of sine of 3x. That's going to be, derivative of sine is cosine. My 3x stays the same. Now I need a chain rule again. So I'm going to take the derivative of 3x, and that is 3. Rewrite it to make it look nicer. We're going to have 3 cosine of 3x times e to the sine of 3x. So that is a nesting chain example. Got a few more. This next one, another one where I'm going to have to do multiple chain rules. First thing I want you to keep in mind is that when I have cosine cubed, this is the same thing as cosine of 2x, all of that cubed. So my outermost function is x raised to the third power. My second one is going to be cosine of x. My third one is going to be 2 of x. So I'm going to start by taking the derivative of x cubed, or just stuff cubed. Bring down the 3. All of the stuff stays the same. Decrease your exponent by 1. Keep in mind all of your stuff stays the same. Now chain rule, I want the derivative of cosine of 2x. Derivative of cosine is negative sine. Your stuff, your argument stays the same. Now take the derivative of 2x. Derivative of 2x is 2. Simplify, I'm going to combine like terms. So 3, or not combine like terms, sorry. I'm just going to simplify. 3 times 2 is 6 times, and I'm going to say negative 6 because of our negative. I have negative cosine squared 2x times sine of 2x. Okay. Next, notice we have a product rule. So we could have chain rule inside of a product rule. So dy dx. One of my functions is x. My other function is natural log of sine of x. So for my product rule, I'm going to start by taking the derivative of the first function. Derivative of x is 1. Leave the second function. Plus, now leave my first function. I'm going to leave the x. Take the derivative of the second function. So derivative of natural log is 1 over x. So I'm going to say times 1 over my argument. My argument is sine of x. Now sine of x is in the argument of natural log of x. So I need to take now the derivative of sine of x. Derivative of sine of x is cosine of x. Simplify, I have natural log of sine of x plus x, not c, sorry, x. Cosine over sine equals cotangent of x. So I'm going to say x, cotangent of x. We have one more. We could have chain rule with quotient rule. So that's this next one. Okay, so let's do it. My outer function is, I have stuff raised to the 9th power. So x to the 9th technically is my outer function. Your inner function is this x minus 2 over 2x plus 1. So for my derivative, I'm going to start by taking the derivative of the outer. So bring down your exponent, decrease your exponent. All of your stuff stays the same. Now I need to take the derivative of the inside function, and the inside function is a quotient. So I'm going to do my quotient rule. So I'm going to square the denominator, and I'm going to do low d high. So derivative of the denominator, or sorry, just the denominator times the derivative of the numerator. Derivative of x minus 2 is just 1, minus my numerator times derivative of the denominator. Let's simplify from there. I'm going to have 2x plus 1 minus 2x plus 4 when I do all that distributing. My 2x's cancel. And then notice that you have 2x plus 1 to the 8th and 2x plus 1 squared, all in denominators. And then I also have 4 plus 1 right here as well. So I'm going to have, let's see, I'm going to say 9 times x minus 2. Let's do one more step. Oops, not equals. Times 5 over 2x plus 1 squared. Now I'm going to do 9 times 5 is 45. My numerator is going to have x minus 2 to the 8th. My denominator is going to have 2x plus 1, and then I have my exponents. 8 plus 2 is 10. And I'm going to make that my answer. So these are a few examples of using the chain rule. Thank you for watching this video.